Module 1, Lesson 15, we're going to focus on our ability to solve equations, but we're going to do them in a way that is joined by the terms and or. So our instructional outcomes say to solve two inequalities or equations joined by the word and or by the word or. They want us to also create graphs of the solution set on the number line and describe the solution as a set of two equations or inequalities. So the focus here is going to be to look at each of these systems or equations, and we note here we see the word or, here in part B we see the word or, in part C we see the word and in part D the word and. So it wants to solve each system of equations and inequalities. And so when we look at this, really for the most part in terms of solving, it's not that bad. It becomes two parts. You see a part right here, that is the x plus 8 equals 3, and you have the second part right here, which is the x minus 6 equals 2. So if I just solved each one, I would subtract 8 on both sides of this particular equation, and x is going to equal negative 5. If I came over here, I would add 6 on both sides, and so x would equal to 8. And so in this perspective of thought, x is equal to negative 5 or 8. So if I represented that on a number line and my negative 5 was over here and then my 8 was over there, that would be my two solutions. And so then I would go in and I would put a closed circle on negative 5 and a closed circle on 8. If I came over to part B and did the same thing, we note that what's going on is a two-step equation. So I would start by adding 9 to both sides. So I get 4x is equal to 9. Divide 4 on both sides. And so x will equal to 9 divided by 4. If I look at the other part, I would subtract 5 on both sides. So I get 3x is equal to negative 3. And if I divide by 3 on both sides, x will equal to negative 1. Same thing down here. If I had x minus 6 equals 1 and x plus 2 equals 9. And so we look at this situation, I would add 6 on both sides. And so x would equal 7, and right here minus 2 on both sides, and x would equal 7. Over here we have 2w minus 8 equals 10, so we will add 8 on both sides, so 2w will equal 18. And then we divide by 2 here, and so w would equal 9. Now what makes D special case, it says right here w has to be greater than 9. Now what we didn't previously discuss is what it means to be an or versus an and. For an or, as long as 8 over here in part A is negative 5 or 8, then this is considered true. In part B, same thing, it's an or, so as long as one of these two numbers occurs in a situation, then it's true. In C, in order for the true statement to be there, it needs to be equal to 7. But in part D, because this is equal to 9, and w has to be greater than 9, well, that's a problem. There's no way something can be equal to 9 and it be greater than 9. So the technical set for this one is called the empty set or the null set, or basically no solution. So the students are given an opportunity to work in pairs here for exercise number 2. And they're encouraged to use a colored pencil in class for this. It says, using a colored pencil, graph the inequality x is less than 3. And since the box is in red, I'll do it in red. So x is less than 3. We go over to 3. I'm going to put an open circle, and I'm going to shade everything to the left. Now, the next instruction is asking us to consider is in part B, Let's take, using a different color pencil, I'll use blue, graph the inequality x is greater than -1. And so here's -1, and I'm going to basically shade everything that's to the right. And what we want the students to understand in this design is using your pen or pencil, darken the section of the number line where x is less than 3, and that's what we're looking for, and is greater than -1. So really what becomes the solution here is the notion that we have this part here shading over to here and including this. This purple region is what both of those inequalities have in common. Whereas you can see over here, this is just the red part versus this is just the blue part. And so we're looking for common shading regions or common shading areas. Same thing occurs in exercise number 2, so the students are given an opportunity to try again. So this time x is less than -4. And so we shade everything to the left. And this time in blue, we're going to shade everything where x is greater than or equal, well, which is greater than 0. And now one thing that you're going to note this time is when we get to part F, using your pencil or pen, darken the section of the number line where x is less than -4 or x is greater than 0, and that's just what we see. In an OR case, it is often easy to note that this is what a graph is going to look like for an OR versus this is what the graph is going to look like for an AND. So in AND you have common shading, and in OR it's quite often that you will have shading that is in the opposite direction of each other. So we just looked at a couple of examples. In part A, graph each compound sentence on the number line. So x is equal to 2. Okay, well x is equal to 2 right here. Or x is greater than 6. So 6 is right here on the end. And that will actually be an open circle at 6 and then shaded to the right to represent that direction. In part B, x is less than or equal to -5, so we'll put a closed circle on -5 and shade to the left. Now note that it says OR, so we're expecting a certain characteristic. We're looking for this characteristic where it's going to shade in opposite directions. So it says x is greater than or equal to 2, and so we'll put a closed circle here and shade everything to the right. In part C, rewrite the compound sentence and graph on the number line. And so here we see x is greater than 1. And so we have a closed circle on 1. And x is less than 3. And so we put a closed circle here. And we're going to shade everything in between. This is typically known as our AND scenario. And will not always have the word AND listed in it. Sometimes you can see it where x is in the middle of two given values or sandwiched in between a pair of inequality signs. And finally, in exercise 3, a scenario is presented where it says students are to present a persuasive speech in English class. The guidelines state that the speech must be at least 7 minutes and not exceed 12 minutes. So when we take a look at that and we want to put that together, we may set up a variable, any variable of the student's choice. So we might let the variable be x. And when we write the inequalities, we would say, well, x has to be at least 7 minutes, but it has to not exceed 12 minutes. So x needs to be less than or equal to 12. If we put that together, we can put a 7 here on the left. We can put our inequality sign sandwiched in between, telling that our minimum value has to be 7 and our maximum number needs to be 12. So maybe if I label this as 7, 8, 9, 10, 11, 12, a closed circle here, a closed circle here, and we'll shade everything in between. And so there is a part B to this. If you're interested, take a look at your child's work manual and take a look at part B. It'll be an OR case to take a look at. and so forth. So hopefully this video has helped clear up a little bit about and or, and just anything else to give you a little bit more practice.